Hello and welcome to part 2 of lesson number 3, rational exponents in our unit 6 exponent laws in our grade 11 University College math class. Whew, okay, part 2, let's get into this. So we've learned what radical form is and we are going to just jump into evaluating without a calculator. So here we have 49 over 25 to the exponent 1/2. Now, we haven't seen one yet with a rational base and a rational exponent. So I would say that when you write a radical form, you can write it under sort of one supersized radical sign, or you can write it as there being a radical sign over the numerator and a radical sign over the denominator, and we're applying that to both. It's up to you. Doesn't really matter which one you use. We're not going to see enough of them for me to necessarily show a preference either, but whatever one you prefer. I think the second one is nice because it shows you that you are finding the second root of both 49 and 25 and then taking those numbers and raising them to the exponent 1. So let's work that side, I guess. So the second root of 49 is two numbers multiplied together to give you 49, and most of us will know that is 7. Two numbers multiplied together to give us 25, that's going to give us 5. Both of these raised to the exponent 1. Fortunately for us, that just gives us 7 over 5. Okay, so we've worked through, let's go right up to the beginning. We worked through a regular one, I guess you would say. We've worked through one where we have a negative base and we have an odd root, which turns out to be okay. Down here, we have done with that has 2 steps, finding the root value and then applying it to a numerator that's something other than 1. Then over here, we worked through one with a rational base as well as a rational exponent. Now we're going to introduce the negative rational exponent, which is kind of the crown jewel of this unit. So let's start by addressing that negative value first before we start to work through the radical form. So how do we deal with a negative exponent? Well, we're going to invert our base. So that's going to give us 1 over 125. Whole thing is now going to be to the exponent positive 2/3. And now is when we would go to radical form. So radical form, I'll do a supersized version this time. So that's going to be 1 over 125. The 3, which is my denominator, goes in the scoop. And outside of this whole thing, the exponent to the numerator. Okay, so we were being asked to find the third root of 1 and the third root of 125. Now the third root of 1 is pretty straightforward because that's going to be 1, which is pretty great. The third root of 125 is what number times itself 3 times is going to give you 125. So as usual, I would recommend that we start with 2. So 2 times 2 times 2, which gives us 8. And then we have 3 times 3 times 3, which gives us 27, 4 times 4 times 4, which gives us 64, 5 times 5 times 5 gives us 125. So we found it at 5, which is nice. If you need to write that out long style, please do. And now we need to square it. Now again, I've been highlighting this. The third root of 1 over 125 is 1/5. That's what's happening in that step, is I found what the 1/3 of 1 over 125 is, and now I've replaced it. Now I need to square it, and remember, you need to square both numerator and denominator. So 1 squared is 1, and 5 squared is 25, and that is our final answer. So stepwise, addressing the negative exponent first, putting it in radical form and addressing the scoop number, the root, and then applying the exponent that's outside the bracket. That was kind of how we did it. Okay, let's have a look at F. Okay, the return of the negative base and the negative exponent. So let's deal with the negative exponent first. That's going to be 1 over negative 32 to the exponent positive 2 over 5. And now we'll jump to radical form. So radical form, maybe I'll do 2 this time. Radical form, so we have a 1 and a 5 and the 2 over, now I'm keeping negative 32 here in the denominator. Ideally you don't have negative things kind of going on in your base there, but we're going to let it ride anyway. Okay, so we want to find the 5th root of 1. Well, that's pretty straightforward, 1. And the 5th root of negative 32. So again, start with 2. 2 times itself 5 times is going to give us 32. But remember, this is a negative 32, and it's okay because we have an odd root here. So that's going to actually be negative 2 that we have there as the result of finding the 5th root of negative 32. That comes out to negative 2. And now we need to, oh, I guess I did it this way. So we need to square each of these guys. So 1 squared is 1, negative 2 squared is going to give us 4, and there's our answer. So again, hopefully this is making sense. I'm kind of just going through it fairly quickly. At any point, if you want to pause and try a few of these on your own and then sort of see how they turn out when I go through them with you, that might be really beneficial about now. Okay, 1,000 to the exponent 1 over 3. No negatives to deal with here, so let's jump right into radical form. There's our 1,000. There's our denominator, which is 3, and our numerator, which is 1. So the third root of 1,000, as we remember from the last lesson when we were working with actually maybe this was in the first lesson actually, when we're dealing with sort of like hacks of powers of 10. So if we have 3 zeros in there, that's going to be a base of 10, which is nice. So the third root of 1,000 is 10. To the exponent 1 is going to give us 10, which is nice and tidy. Let's have a look at the next one. 16 to the exponent 3 over 4. So let's start with radical form. 16, 4 in the scoop, 3 goes outside. So the fourth root of 16. So again, I know I keep saying it, but I want to just keep saying it so you get it. Start with 2. This is going to be a whole number. If I'm asking you not to use your calculator, I'm not going to make these weird, difficult decimal numbers. So 2, maybe I'll just write this one out. 2 times 2 times 2 times 2 does in fact give us 16. So the fourth root of 16, i.e. what number times itself 4 times that gives us 16 is going to be 2. But we haven't dealt with that cubed yet. This last step here is doing 2 cubed, which is 2 times 2 times 2, which is 8. There it is. And let's get over to I over here. So we have now a rational base, a rational exponent that is negative. So how do we deal with that negative exponent first? Well, we're going to invert our base. So we're now going to have 27 over 64 to the exponent positive 2 over 3. So let's go with radical form now. I'm going to make a supersized one again. Whoops. I'm going to make a supersized one again. 27 over 64. In the scoop, we have our 3, and outside of that whole thing, we have our 2. So we want to find the third root of 27, and then the third root of 64. So hopefully you're starting to become a little more familiar with these. We know 2 is not going to work, right? Because 2 times 2 times 2 is only going to give me 8. But 3 times 3 times 3 is going to give me 27. And 4 times 4 times 4 is going to give me 64. So this third root of 27 over 64 is 3/4. That's what we've done there. But we haven't yet addressed this squared outside, which will give us, when we square both the numerator and the denominator, 9/16. So we're kind of rocking. That's the last one that we're going to do of this type. Now the bottom ones are here just for your calculator. So because I'm not there to help you with your calculator, this is going to be a little bit problematic, but I will show you how to type it in. So here we have 0.008 to the exponent 4 over 3. So here's how I would recommend typing it into your calculator. I'll show you a couple different ways. So 0.008. Now to the exponent is sometimes a button like x to the exponent y, sometimes it's a button like y to the exponent x, and sometimes it's a button that looks like sort of a little hat. Whatever one of those buttons it is on your calculator, that's the one that you want to put in. And then you're going to, now because we've got 4 over 3, that's going to be 1 1/3 or 1.3333 repeating. So that's kind of hard to estimate in your calculator, so let's not bother doing that. Let's do bracket 4 divided by 3, close bracket, equals. And that should take us to our answer. So I'm going to type that into my calculator right now, 0.008 to the exponent. I have this guy on my calculator, y to the exponent x. To the exponent, open a bracket, 4 divided by 3, close the bracket, equals, and that gives us, whoops, that's a highlighter, equals 0.0016 is what we should get if we're typing this properly into our calculator. And again, this is not the kind of thing that I would put on the test. It's just to get you a little more familiar with how the buttons on your calculator work in anticipation of the things that we're going to be doing in both Unit 7 and Unit 8. So let's try another one of these. So 22 to the exponent 1 over 3. So again, I would type this in as 22, and then whatever your exponent button is, for me it's y to the exponent x, could be x to the exponent y, could be, like I said, a little hat on some calculators, and then open a bracket, 1 divided by 3, close the bracket, and hit an equal sign, or hit the equals on the calculator. So let me type that in. We're going to have 22 to the exponent, open a bracket, 1 divided by 3, close bracket, equals 2.8. Did it say? It didn't say how to round them. So we'll go to one decimal place here. That's convenient. So 2.8. Let's work the last example. So again, we've got a negative in here. It's not a problem. Write it in the same way. So we got 54 to the exponent, whatever it's going to be. I'll just leave it at 1 this time. And then I open up a bracket. And now I'm going to type in, and this is important too, because on your calculator you can't use a subtraction here. What you'd want to be doing is putting in the negative sign. Now, the ways that you can do this, on some calculators, the button sort of looks like brackets around a negative. On some calculators, it will be like a plus, minus. These are some of the options you might see, but you want to assign it a negative value but not subtract it. And then you would do 2 divided by 3, close the bracket, equals. So let's see what we get. Grab my calculator here. So we got 54 to the exponent, open a bracket, negative 2 divided by 3, close the bracket, equals, and that's going to give us 0.0, it's 69999, so we'll go 0.07, oops, approximately. For that little bit of rounding, I guess we should have been approximating all of these. That's my fault. Oh, I think that one came out even. Okay, so there you go. Hopefully this little bit of calculator stuff at the end. Again, don't fret if you're having trouble figuring it out in your calculator. It's not the kind of thing that you're going to be using here. We'll talk about it more when we get to Unit 7. But this is the end of Unit 6. So tackle the homework. Make sure you're feeling good about rational exponents. We're certainly going to be using them when we head into Unit number 7. So we'll see you in Unit number 7.